Okay. All right, so here we go. So we're looking at 3.3, applications of linear functions. First question, a health club, I could make that bigger, but it would have went off the screen. A health club charges a one-time fee of $80 plus a membership fee of $10 per month. Choose an expression for the total cost of the health club. So it's a one-time fee of $80, and it's $10 per month, and they're saying, what's X? Oh, X is the number of months on that. So, yeah, you guys are right. It's C. It's 80 plus 10X, isn't it? Let me help with that in case that's confusing. You know, with word problems, one thing I learned to do is whenever they give me an X, to just put in a number instead of X. Like, let me put in 7, for example. I noticed how much better I think with a number than I do with an X. X is just kind of weird. What if somebody said, hey, look, I'm going to do this club thing, and it's $80 and then plus 10 a month. I'm going to go for 7 months. I think every one of us in here could quite easily figure out what the total bill will be, right? 7 months at $10 a month plus the sign-up fee of $80, the one-time sign-up fee of $80. You would just go 7 months times $10 a month, and you would add the 80, wouldn't you? Whatever that came out to be. I don't care about the answer as much as the process. Isn't that what you would do? And then think, well, what did I do with the 7? Do that with the X. What'd you do with the 7? Oh, it went right there next to a 10, and 80 is added. It doesn't matter what order. You can put it this order, that order. It's all the same. That's how we know that's the right answer. Does that make sense? We think better with numbers than we do with letters, so just put in a number. So that's it. Questions on that one so far? So I encourage you to write those down in your notes, but this will all be on YouTube as well later, so that way I can kind of go faster, and if you miss anything, it'll be on YouTube, and I can get to the harder ones, is my hope. Number 2. So you see I'm on question number 2, section 3.3. This is exactly what you'll see in the homework. A parking garage charges a one-time fee of $7 plus $150 per half hour. And X is the number of hours. Same thing as the last one, huh? Have you noticed that the per always goes with the X? So 150 per hour. So that's going to be 150 times the X. And the 7, you can have the 7 on the right side or the left side. It doesn't really matter. The order of adding things is switchable, changeable. Commutative is the official math word. So there we go. Which one? That one's B again. Or I don't know if the last one was B. There it is right there. Is that good? Is it D? Oh, you're right. That's not B. I was just testing you. Well done. No, I'm messing up. Yeah, it's per half hour. I got to read the words carefully. And X is hours. Yeah, so if it's $150 per half hour, it's $3 per hour, isn't it? Messed up. Yeah, they're being tricky. I didn't notice that. Yeah, it's D, thanks. Yeah, everybody see that? It's $1.50 per half hour. I didn't read carefully. And so that means it's $3 for a whole hour, isn't it? So it's 3X. Yeah, good eye. Good job. Okay. Hopefully you can see that okay. Okay, so it spends, what's that, 23,000, there's the comma, 23,000 for 140 parts, marginal cost of 155. Marginal cost of 155, and they want me to find the linear cost function. This is a more tricky question. What does that word marginal cost mean? Yeah, a margin is the small, when you see the word margin, think small. It's a small part of the paper, right? It's the edge of the paper. Margin means the cost of one more item. Yeah, additional cost, another way to put that, right. So marginal cost, let me write that down. Marginal cost is the cost of one more whatever we're talking about in the problem. It's the cost of one more. It's just a little bit, like margin's little area. It's the cost of one more whatever. So that means whatever it is we're making these parts, we're making parts here. It cost them $23,000 to make all 140 parts. Okay, but the cost of each part, of each of one. Let me say that more carefully. Of one more part, and I'll show you why that matters in a second. Is $155. So the 155 goes right there. Is what that means. That's the per cost. In other words, that's the cost per one item. Does that make sense? That's like in the last problem where they said, well, they did a trick on that one. This one they said $10 per month. Well, then the 10 goes next to X. The per goes next to X because it's per each item. That's what marginal means. Marginal means one item. So the 155 goes there. So cost is 155X. So far, so good. And then what goes at the back, though, I'll just put a question mark for now. They had C of X. You can put the X if you want it. It does. I'm just going to call it C. It doesn't matter. That X is just a function spot. It doesn't matter. So I've almost got it, but I have to find out what goes at the back. What goes at the back is the one-time cost, isn't it? Like in other words, for them to produce 140 parts, they have to make a machine, and they have to pay for the whole machine that'll crank out these parts. And there's a cost to make that machine before even one part has been made. And then it cranks out parts using the steel or whatever that cost them $155 per part in steel to crank out once the machine has already been purchased. So out here is the one-time cost. That's how these other ones worked as well, right? Right? The 80 is the one-time cost, and the 10 is the per. Whatever's next to X is per item. Whatever the other part is the one-time upfront cost to get the whatever going. Making sense how that works? So therefore, I've got the 155, the per item cost. I need to figure out now the one-time cost. So how are we going to figure out the one-time cost? Any ideas? They're not telling me the one-time cost. Let's use the information they gave us. What can I do with those two things? They're giving us that for a reason. What can I do with those? 23,000 is the cost when you have X being 140 parts.
We need just 155 times 140?
155 times 140. Yeah, right. Correct. Yeah. So the cost will be 23,000. That's the total cost, right, of making 140 parts, including, let's call this B if you want. I'm just doing the Y equals MX plus B. You can call it whatever you want. I'm just putting a letter back there. Sure is a pink hue to that, huh? It's weird looking. Anyway, everybody see what I'm doing so far. I'm taking the basic formula that they gave me. You know what it's like? It's like slope formulas from algebra. MX plus B. Maybe that'll help you. So let me write it that way for you. It's just like cost or Y equals MX plus B. This is the M. This is the B. The M is the slope. I don't know if you remember from algebra, but a slope, that's exactly what rise over run, and it's a per, because the slope is rise in Y over run in X per X unit. So it's the same thing. It's the same concept. So therefore, whenever they tell me the cost of the marginal cost or the cost of one item, that's my M. It's like giving me my slope. And then I need to find the B, the one-time cost. How do I do that? Well, they told me total cost is $23,000 for producing 140 parts. So now I can solve that equation for B. So let's do it. You're going to need a calculator. You guys can use calculators on everything. So 155. Oh, yeah, so you might not need a scientific calculator. I'm getting confused. I'm getting confused with my pre-calculus class because they need the two. Hold off on that. You might not even need a scientific. If you have graphing, I don't know why you would need a scientific in here. You don't need that. Yeah, and I'm just getting confused with my pre-calc. I have 3 pre-calc classes this semester, so I just got pre-calc on the brain. They need both because of something else they're doing. You don't need scientific. The graphing will handle everything. Yeah. Anyway, getting back to it. Somebody have a calculator? What? I can't do it. What's 155 times 140? Oh, I got a calculator. Is that what it is? Whoops. Wait, one more time. 700, thank you. Plus B. How do we solve that little equation for B?
You would just take away the 21,000 from...
Correct. Yeah, subtract the 21,000. Remember algebra? Subtract 21,700 from both sides there. Is that okay? Bring it over here. and subtract that. I think it's going to be 1,300 is B, because these cancel. So B alone is 1,300. So now we have the overall, that's what goes back here. So the cost is 155x plus 1,300. Let's go back. I'll come back to. Okay, so on this one, find the average cost per item. So how do you do an average? Like say you get a 83, 91, and 87 on your 3 exams in this class. How would you find out your average? Add them and divide by 3, right? So you guys know that. Average is always total divided by number of items, right? That's how we, kind of scribbly there, that's how we figure an average. Right, well that's exactly what we do here too. Well, they just say, okay, they give me this formula, I'll just write C equals 45x plus 1,300. They're saying 50 items. So what do I do with that 50? Where's that 50 plug in? In the x, right? So plug in that 50. And we'll get the cost of 50 items. What is 45? 2250, I think. 225, yeah. Plus 1,300. And then add that up. What's that? 3, 5. I think I did that right. Feel free to check my math. Let me know if I messed up. 35.50. That's the cost, but that's not yet the average cost. I have one more step. Good so far? That's just total cost, if you want. That's the cost of 50 items. That's what that formula is doing. That formula is saying every item costs $45 to make itself, plus the initial startup fee to build the machinery or the warehouse or whatever of $1,300. That's what that formula is saying, like the other ones. So if you 50 items, you just plug in the 50 times $45 per item plus the startup fee. So to crank out 50 items will cost the factory $3,550 total. Now what they want to know is, what is the average cost per item? Because that'll tell them where they need to set the prices at if they want to make profit. So how do we find that's the total cost. How do we find the average now? Yeah, just divide it, huh? So the average cost, and what they call average cost is with a bar. I don't know if you've seen that before. A bar over something means average. So it would be the 35.50 divided by the 50, huh? Because there were 50 items total. And whatever that is, I don't know. 71? Thank you. So $71 is the average cost per item. I wonder if that's confusing. If I was you, I might be thinking, hey, wait a minute. You said it's $45 per item. Yeah, it is, but there's also the startup cost. So they're saying including the startup cost, the average is a little more, 71. So if you're just going to make 50 items, if your whole factory is just going to make 50 items, it's going to cost you $71 per item. The more items you make, the lower the average cost goes down because you don't have to redo that startup cost, huh? That's, how business is thinking, of course. Is that good on that? Feel free to. Okay, so Amira's car is worth $14,760. Let me just tell you right off the bat, we're going to again be using mx plus b. All these, how do I know? Linear. Whenever they say you're using a linear function, you're using y equals mx plus b. That's linear, meaning if you graphed it, the picture would be a line. That's what a linear function is. We'll also get to functions that you've probably seen in algebra, like u-shapes, and exponential, and logarithmic, some other kind of functions too. But this is a linear function, which means the graph would be a straight line if I was to bother to graph it. And linear also means x first power and y first power. That's how you can tell if an equation is linear. X and y are first power. If you had something like y equals 3x squared plus 7, that's not linear because x is squared. When you bring in higher powers, that brings in curvature into the graph. That would be, you might know from algebra, that's a U-shape. Parabola graph is what that one is. Anyway, so they're saying, okay, I saw that word linear, and I went, okay, we're talking y equals mx plus b kind of formula. You can call it c equals mx plus b or whatever you want. Doesn't really matter what the letter is. Now, in fact, yeah, instead of Y, how about I do V, which stands for value? It'd just be a little more meaningful, I think, easier for us to think about. V for value. And the last one we use C for cost. You know, it's whatever we're talking about. Value of the car in this case. So her car is worth $14,760 and expected to be worth that in 5 years. Okay, expected to be worth that in 5 years. The years, X is going to be the years in this one. The years old, let's say. Years old. Those are the two things we're talking about. Value and years old. So they're telling me that the value is $14,760 when the car is now, which means 0 years old. I actually don't know it's new, but it's just a comparison to this, which is 5 years later. So they're telling me the value is going to be $9,235 when X is 5 years old. Let me stop there. I know that's kind of tricky, what we've done so far. Let me let you digest that for a second. I'm going to plug these into the formula in a minute. But first off, let me help you see where I'm getting that information from. They're saying the value of the car is $14,760 now. Now means 0 years old. Remember, X is years old? So 0 years old, meaning now. And then the 5 is, 5 years from now, in 5 years. In 5 years, it's got a lower value. Okay, so let me go to a fresh screen, and I'm going to do that. So again, we're taking value is mx plus b. X is years old. So the first piece of information I will plug in. 14,760 value at 0 years old. Everybody see what I'm doing there? So I plugged in that first bit of information. This is the value now at X is 0. So I plugged in value 14,760 and X 0. So what can I do with that? I'll get to the other information in a minute. What's m times 0? Just 0, it's just gone. 0 plus b, that's just b. So that tells me, doesn't it, what b is? 14,760, that's the base price of the car. 14,760. Now I'm going to reuse that. So here's the first usage of that formula, and here will come the second. This is a harder problem. We only got a couple minutes left. This is the second usage of that formula. Second usage, this is value. This is X 5 years old. So the value is 9,235 when X is, not 2, but 5 years old. Plus B. Does that make sense there? And I know what B is. From part 1. So now I can solve that equation for M. Does that make sense how I did that? So I'm using V equals mx plus b twice. First time, value 14,760 at 0 years old. Got B. Started again, value 9,235 at 5 years old. Put in the B, and you can solve for M. So, 9,235. Oh, wait. What am I doing? Well, to solve for, here's the equation. M is saying, I want to be alone, get rid of all this other stuff. So what should I do first to get M alone? Yeah. Subtract the 14,760. And it's going to be some negative number, huh? That's going to be negative 5525 equals m times 5. And now what do I do to finish getting m alone? Divide by the 5. Remember your algebra days, all these kind of steps. And what is that? Divide by 5. I'm getting negative 1105. Yeah, it's negative. That's the depreciating. That's the going down in value. So what's our overall formula then? So now that we've done all that, we can put a final formula together. Value is mx plus b. So we found the m, negative 1105. X plus b, and the b was right there, 14,076. So that's the formula. With that formula now, you could predict how much the car is going to be worth 10 years from now, 15 years from now. Whatever x you want, you can just plug into that formula. Remember, x is how many years old. So then they're going to ask in part 2, what about if it's 7 years old? So you would just plug in a 7 right there for x and hit the buttons on your calculator. Find out the value. So that 1105 means how much it's going down every year. It's going down $1,105 per year. My old van's is done going down now. All right, well, we're out of time. We'll need to stop there.